Jai Shri Gurudev. Good morning to everyone student. Welcome to chemistry class. In this session we are going to study a new chapter. It is very interesting chapter, that is classification of elements and periodic properties. After knowing the structure of an atom or line spectrum of an hydrogen atom, then we know well how the electrons are filled in an orbiters according to Ohm's rule, Hubble principle and Pauli's exclusive principle. We are going to study the classification of elements and periodic properties. In this chapter we learn how the elements are classified into different groups or periods, on what basis we are classified it. Then what are the properties of these elements, how they are responsible to each other and how they vary to one another. That is the main concept we are learned in this chapter. Okay, so here to give an exact or a clear picture of a modern periodic table, before that many of the people do exercise to give a clear picture of a periodic table, but they are failed due to some disadvantages. Now finally, in the circle of 1913, Henry Moseley was given a modern periodic table. Okay, how they are given means, in the year of 1913, Henry Moseley during his studies about the X-ray characteristic analysis of an element, he observed that the radiations are emitted from an atom is based on the atomic number of an element. Okay, ಅಂದ್ರೆ ಹೆನ್ರಿ ಮೋಸ್ಲೆನ್ ಅವರು 1913 ಅಲ್ಲಿ ಅವರು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದಾಗ ಯಾವುದರ ಬಗ್ಗೆ, ಎಕ್ಸ್ರೇ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಅನಾಲಿಸಿಸ್, ಎಕ್ಸ್ರೇ characteristic analysis about of an elements ಬಗ್ಗೆ X-ray characteristic analysis ಮಾಡ್ತಿರುವಾಗ, the emit radiations means the metal emit or element emit radiations that is based on atomic number, not atomic mass or weight ಅಥವಾ mass ಮೇಲೆ ಕನ್ಸಿಡರ್ ಮಾಡೋದಿಲ್ಲ. It emits only an atomic number, so that he says that the properties means both physical and chemical properties of an element is depends only on atomic number. ಅಂದ್ರೆ ಇದರಿಂದ ಇವನು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ, ಯಾವುದೇ ಒಂದು ಎಲಿಮೆಂಟ್ ನ ಫಿಸಿಕಲ್ ಮತ್ತೆ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನೋದು ಅಟಾಮಿಕ್ ನಂಬರ್ ಮೇಲೆ ಮಾತ್ರ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, ಅಟಾಮಿಕ್ ಮಾಸ್ ಅಥವಾ ವೇಟ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರೋದಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾನೆ. Based on this concept, he defined a law that is called modern periodic law. So here the syllabus is began from modern periodic law. Now take first one, modern periodic law. Modern periodic law, important for one more. This modern periodic law is proposed by the scientist Henry Moseley. He says that, or the modern periodic law says that, the physical and chemical properties of an element is the characteristic properties of the atomic number of an element. Okay, so that is right. The statement of modern periodic law is, the physical and chemical properties of an element is the characteristic properties of their atomic number. So already you know the definition of atomic number. Okay, so the physical and chemical properties is depends only the atomic number of an element, that is called the statement of modern periodic law. So on the basis of this, they arranged a table means the atoms are arranged in a particular manner on the basis of physical and chemical properties. That is called modern periodic table. Now take modern periodic table. So modern periodic table is a table in which the atoms or elements is arranged in the increasing order of their atomic number, and the chemical and physical properties of each group will be remain same, not varied. Such kind of table we called as a modern periodic table. Okay, so observe here. So listen, this is the statement or definition of periodic table. This periodic table definition is that the statement is the modern periodic table is a table in which the elements are arranged in increasing order of their atomic number, and the elements having same property or similar properties fall into the same group. Okay, listen here. This is the modern periodic table. See, this is the modern periodic table. It consists of 118 elements. 118 elements. See here, 118 elements. Here, these elements are arranged in increasing order of their atomic number. See, this is the first element, hydrogen, having only one atomic number. And the second one is helium. Its atomic number is 2. So, increasing order from left to right. Then the third one is lithium. And the fourth one, beryllium, atomic number is 4. Okay, by adding one electron, the charge of an atom is increases by 1. Hence, the neutrality of an atom is satisfies. Okay, that is only we have studied in the previous chapter in structure of an atom. The atom should obey the neutrality. Okay, so here by increasing the one charge and adding one electron, the neutrality of an atom is obeys, means satisfies. And the boron, 5. Carbon, nitrogen, oxygen, fluorine, neon, like that, the increasing order of their atomic number, we are arranging these all elements. And the second statement, observe here, and the elements having similar properties are fall in the same group. So these are the groups. The horizontal columns. These are the horizontal columns. These horizontal columns are called groups, and the vertical periods. These vertical periods or vertical rows we call as periods. ಈ ತರ ಅಡ್ಡಡ್ಡವಾಗಿರುವಂತವೆಲ್ಲ ಏನಂತ ಕರಿತೀವಿ, ಪೀರಿಯಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಈ ತರ ಕಂಬಸಾಲುಗಳಾಗಿದ್ದಾವಲ್ಲ ಇವನ್ನೆಲ್ಲ ಗ್ರೂಪ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Okay, so here same group means the hydrogen family we called our hydrogen group, and beryllium family or beryllium group or we called second group. So here observe the given number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that, so on. There is 18, 17 and 18. Means there are 18 columns, means 18 groups and 7 periods. See, 1, 2, 3, 4, 5, 6, 7. There is 7 periods, right? Andre 7 period idave, ಈ ತರ 7 periods and 18 columns. ಈ ತರ groups 18 idave. So the periodic table consists of, listen, the periodic table, this one consists of 18 groups and 7 periods. Okay, so listen how to remember 7 periods. We are writing like P. This P is called what? Like the horizontal. This is the horizontal rows. And 18 groups. G is writing like that, right? Means like perpendicular. Sorry, like straight line. ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಉದ್ದವಾಗಿ ಬರೀತೀವಲ್ಲ, ಸೊ G. P ಅನ್ನು ಈ ತರ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಳ್ಳಿ. That is 7 periods and 18 groups. That is present in periodic table. So here the same group element having similar properties. It means the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These elements having almost similar properties. Similarly, beryllium, magnesium, calcium, strontium, barium, radium. These elements also same properties, means similar properties. And these elements like that, each group elements having similar or almost same properties. Like that, we are arranging all these elements. This chart or this table we called as what? Modern periodic table. Why we called modern? Before we getting this table, many of the people arranged elements in their own rules or own laws, but that is not satisfies or not obey the all conditions of an or properties of an element, so that they are failed. And finally Henry Moseley was given this chart. So see here, the Moseley name is there. He is the scientist Moseley. So observe, here is the scientist Moseley. He only given modern periodic table with the help of Mendeleev. Okay, so this is the modern periodic table. So listen, this is modern periodic table, or we also called as a long form periodic table. Long form because there is a number of elements in the each period. One period ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ತುಂಬಾ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ. ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ಲಾಂಗ್ ಫಾರ್ಮ್ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಅಥವಾ ಮಾಡರ್ನ್ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸಿ ಹಿಯರ್ in first period, so this is the 7 periods and 18 groups. 18 groups ಇದೆ, 7 period ಇದೆ. In first period, this is the period, means so horizontal rows we called as periods and vertical columns we called as what? Groups. Remember. Now first period, this is the first period, second, third, fourth, fifth, sixth, seventh. In first period there is 2 elements only, one is hydrogen and helium. In second period there is 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. There is 8 elements in second period, that is lithium and beryllium, then boron, carbon, nitrogen, oxygen, fluorine, neon. This is the second period. Elements consists of how many elements? 8 elements. Similarly, see the third period, that is sodium. Third period, sodium, magnesium, then aluminium, silicon, phosphorus, sulfur, chlorine and argon. This is the third period, that is also containing how many elements? 8 elements. Okay, so these are the first group. First period containing how many elements? 2. The second containing 8, third containing 8, then fourth one. So this fourth one is called potassium period. This one, fourth period consists of 18 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18 elements. The fourth period containing 18 elements. Then fifth one also containing 18 elements. See, the fifth one, same elements, right? Fifth one also containing 18 elements. So 18 and 6, 7. There is 7 periods. So observe, the sixth one also containing 18 elements here. But observe the sixth one, cesium 55, then barium 56, lanthanum 57. After 57, here there is 72. See here, 72. There is no 58. Means the 58 element is written here. Cesium. Why we are written here? Because these elements having separate properties and they are called rare earth elements. And we also called as inner transition elements, so that we are separately placed below the periodic table. Okay, so 58, 59, 60 like that, so on. Here 71. After 71, here there is 72. Therefore, this cesium elements we called as lanthanoids. Cesium elements we called as lanthanoids because it is begins with lanthanum. Here is their lanthanum. ಇಲ್ಲಿಂದ ಬಿಗೇನ್ ಆಗೋದ್ರಿಂದ ನಾವು ಲ್ಯಾಂಥನಾಯ್ಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅದಕ್ಕೆ ಈ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಇಲ್ಲಿ ಸೇರಿಸ್ಕೋಬೇಕಾಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? Therefore, totally in sixth period there is 32 elements. Because here in sixth one there is 18 element, 18, 19, 20, 21, 22, 3, 4, 5, 6, 7, 8, 9, 30, 31, 32. Okay. there is 32 elements in 6th period. Similarly, observe in 7th period, francium, radium. Then actinium is 89, see here 89. So after 89 there is 104. Because this is rare elements, means man-made elements, we are still investing these elements. So after 89 here there is 90. Therefore this is the continuation of actinium. So that these elements called as actinoids ಅಂತ ಕರೀತೀವಿ. ಈ actinoids ಅನ್ನು ಇದರೊಳಗಡೆ ಸೇರಿಸಿಕೊಂಡ್ರೆ total 32 elements ಆಗುತ್ತೆ 7th period ಅಲ್ಲಿ. Therefore there is 32 elements in the 7th period also. This is the number of elements present in the each period. So ಒಂದೊಂದು period ಅಲ್ಲಿ ಎಷ್ಟೆಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಂತ ಈ ತರ ಅರೇಂಜ್ ಮಾಡಿದ್ವಿ periodic table ಅಲ್ಲಿ. Okay, so here the 1 2 3 4 5 6, this is called n. What is mean by n? In the previous chapter you learned n is nothing but principal quantum number. What is its significance or what it signifies? This n, principal quantum number, signifies the main energy level of an electron or shell. ಒಂದು ಶೆಲ್ ಎನರ್ಜಿ ಎಷ್ಟಿದೆ ಅಂತ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಮೇನ್ ಎನರ್ಜಿ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ಸ್. ಅಂದರೆ ಈ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಒಂದೊಂದು ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಇರುವಂಥ ಫಸ್ಟ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಇರುವಂಥ ಎಲಿಮೆಂಟ್ಸ್ಗೆ ಏನು ಪ್ರಿನ್ಸಿಪಲ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ 1 ಇರುತ್ತೆ, 2 3 ಈ ಥರ ಇರುತ್ತೆ ಒಂದೊಂದು ಪೀರಿಯಡ್ಗೂ. ಓಕೆ, ದಿಸ್ ಈಸ್ ದಿ ಮಾಡರ್ನ್ ಪೀರಿಯಡಿಕ್ ಲಾ ಆರ್ ಲಾಂಗ್ ಫಾರ್ಮ್ ಪೀರಿಯಡಿಕ್ ಟೇಬಲ್ proposed by Henry Moseley in the year of 1913 during his X-ray characteristic analysis about an element. Okay, so I hope you get a idea about a periodic table, how many elements are there and how they are arranged and what basis they are arranged. Okay, so the next concept is electronic configuration of an element and the periodic table. Electronic configuration of an element and the periodic table. So listen, already you know the definition of electronic configuration. So electronic configuration is nothing but a filling of electrons in a various orbitals according to the increasing order of their energy. So here the electrons are filling in various orbitals according to their increasing order of energies by following the Hund's rule of maximum multiplicity, then Pauli's exclusive principle, and the third rule is which one? Hubble principle. Okay, so here we are following 3 rules, that is Hubble principle, and Pauli's exclusive principle, and Hund's rule of maximum multiplicity. So you know well the definition of these 3 rules. By knowing these 2 rules, we are filling the electrons in any different orbitals by their increasing order of their energy. You know energy level diagram of an orbitals, that is written like that. Already you know 1s, 2s, 3s, 4s, 5s, 6s and 7s. Why we are writing only 7s? Because in the periodic table there is only 7 periods. Okay, therefore 7s. After 3s, 2p, 3p, 4p, 5p, 6p, 7p. So this is the energy level diagram right now. Then 3p, then 3d, 4d, 5d, 6d, 7d. Then 4f, 5f, 6f, 7f. Right. Now n is equal to 1 here. N is equal to 1, that is called K shell. So n is equal to 2, that is L shell. There is 2, that indicates the main energy. Then n is equal to 3. So that is called M, K L M. And n is equal to 4, that is K L M M. Then O, P, Q or S on like that. So this is the energy levels are called shell number. So listen, no filling of electrons like that. we are writing arrow, it means filling 1s, then we are going to 2s, then 2p, then 3s, then 3p and 4s. After that 3d, 4p and 5s. Here the energy of 3d means the principal quantum number is 3 here 4, but after filling 4s we are going to fill 3d because the n plus l rule. Are you remember what is meant by n plus l rule? What it says? Okay. Then this is the filling order. Like that, this is the energy level diagram. Remember, based on these conditions, we are studying the electronic configuration of an element. So listen, in electronic configuration, this is the periodic table. The first period, this is the first period, there is 7 periods. Now take the first period. In first period, n is equal to 1. Okay, so see here the n is equal to 1 for first period. It means that the principal quantum number is 1. This first period consists only 2 elements. This first period consists only 2 elements. One is hydrogen and one is helium. It consists only 2 elements, hydrogen and helium. The atomic number of hydrogen is 1 and the atomic number of helium is 2. Okay, so you know the s orbital has a maximum ability to fill 2 electrons only. So that the hydrogen electronic configuration is 1s1 and the helium is 1s2. See here, the s orbital is represented like that for our convenience, and the 2 electrons are filling like that with opposite spin for helium. But hydrogen we are writing like that, only 1 electron. Okay, so the principal quantum number for first period is 1. There are 2 elements only, hydrogen and helium. Atomic number 1 and 2. Increasing order, their atomic number we are writing. Then the second period. So it consists how many elements? Already I told you that these are, remember the rule 2, 8, 18, then 32. Okay, this is the elements. In each period, how many elements are there? That we know by knowing these values. So second period containing 8 elements, right? See, the second period containing 8 elements, that is begins from lithium and end to neon. So the begin element is lithium, its atomic number is 3. Then beryllium, boron, carbon, nitrogen, like that. For a second period element, the n is equal to how much? 2. Okay, second period element, the n is equal to how much? 2. So see here, the first period, s orbital is there only. In second shell, there is 2s and 2p orbitals. Before that, there is 1s also. ಅದಕ್ಕಿಂತ ಮುಂಚೆ 1s ಇದ್ದೇ ಇರುತ್ತೆ ಮೊದಲ atom ಅಲ್ಲಿ. Therefore, the elements is begins lithium, atomic number is 3. Lithium, atomic number is 3. And after lithium, there is beryllium. Then beryllium, there is a long gap and shorted from boron B. So atomic number of B is 5, and the last one ended element is what? Neon. Atomic number is how much? See here, 10. That is neon 10. So now write electronic configuration for this one. 1s2, then 2s1. There is 3 electrons only. 2 and 1, though SR is incompletely filled. Okay, then for beryllium 1s2, 2s2, 4 electrons. After beryllium, boron, it has 5 electrons. See here, the s orbital has maximum ability 2 electrons. It is already completely filled. Therefore, we have to move p orbitals, right? See, 2s after they are moving to 2p. So that for beryllium 1s2, 2s2, then 2p for p orbitals has ability to accommodate 6 electrons, right? So that now we are filling first electron, 1 electron. Still it has ability to accommodate 5 electrons. So that there is 5 elements between here, boron to neon, that is the carbon, nitrogen, oxygen, fluorine and neon. These are the 5 elements. ಅಂದ್ರೆ ಇವುಗಳ ಮಧ್ಯೆ 4 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ, ಟೋಟಲ್ 5 ಎಲಿಮೆಂಟ್ಸ್. ಅಂದ್ರೆ ಪಿ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗ್ಬೋದು? 6. ಸೊ 6 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಯಲ್ವಾ. ಎಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗ್ಬೋದು? 2 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಲೈಕ್ ದಟ್ ದೇ ಆರ್ ಅರೇಂಜಿಂಗ್. This is the second period elements. Similarly, observe for third period elements. Say what is the value of n? What you guess? Exactly the n value is 3. Okay, your answer is right. See, n is equal to 3 here. For the third period, n is equal to 3. See here, how many elements are there in third period? 8 elements only, right? So that is begins from sodium, then magnesium. Here, aluminium, silicon, phosphorus, sulfur, and chlorine, argon. These are the elements of the third period. Here, observe the third period n is equal to 3 and the electronic configuration is 3s1. See here, 3s1 for sodium. Atomic number is 11. Sodium, the atomic number is 11. Write the electronic configuration to get a third shell. N is equal to 3 and this is the first orbit. S orbital means the L value, azimuthal quantum number L is equal to 0, so that the S orbital sodium is the electronic configuration is 3s1. See here. Okay, students, while studying this chapter, you should keep the periodic table in front of you. It will very easy to understand. That is 3s1. So the end element is last one, argon. Its atomic number is what? 18. Or how much? 18. So electronic configuration is 3s2 and 3p6. 3s2 and 3p6 means completely filled for argon. 3s2 and 3p6. This is for argon. So atomic number is 18. Completely filled one. Similarly, for fourth period n is equal to 4. Fourth period n is equal to 4. So potassium and calcium. Here these two, the electrons are filled in s orbitals. After seeing 4s, this is 4s. In fourth shell means in fourth period, the s electrons or s orbitals is filled completely for potassium and calcium. Then for scandium, it will jumps to the 3d. After filling 4s, it moves to the 3d, right? So that for 3d scandium, the electronic configuration is 3d1 and 4s2. The electronic configuration for fourth period scandium 3d1 and 4s2. Its atomic number is 21. Okay, like that. See here, the d orbital is incompletely filled up. The d orbital has ability to fill 10 electrons maximum. D ಅಲ್ಲಿ ಎಷ್ಟು electrons fill ಆಗಬಹುದು? maximum 10 electrons. So now d ಅಲ್ಲಿ 10 electrons fill ಆಗಬೇಕಾದ್ರೆ 1 to 10 elements ಇರಲೇಬೇಕಲ್ವಾ? So see here ಎಷ್ಟು elements ಇದಾವೆ ಅಂತ? 1 2 3 4 5 6 7 8 9 10. 10 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಯಲ್ವಾ. ಸೊ ಇವುಗಳಿಗೆ ಒಂದು ಕಲರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇವನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಯು ಲರ್ನ್ ಲೇಟರ್. ಸೊ ದೇರ್ ಈಸ್ 10 ಎಲಿಮೆಂಟ್ಸ್. ಆಫ್ಟರ್ ದಟ್ ದೇರ್ ಈಸ್ ಎ ಗ್ಯಾಲಿಯಂ, ಜರ್ಮೇನಿಯಂ, ಆರ್ಸೆನಿಕ್, selenium, bromine and argon. So these elements means up to zinc ವರೆಗೂ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ D ಗೆ ಫಿಲ್ ಆಗುತ್ತೆ. ಜಿಂಕ್ ಗೆ ಏನಾಯ್ತು 30 ಅಟಾಮಿಕ್ ನಂಬರ್, ಜಿಂಕ್ 30. ಸೊ 30 ದ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ 3d10 4s2 ಆಯ್ತು. ಅಂದ್ರೆ D ಆರ್ಬಿಟಲ್ಸ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆಗೋದು, S ಫಿಲ್ ಆಗೋಯ್ತು. D ಮತ್ತೆ S ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಏನಿದೆ P ಆರ್ಬಿಟಲ್ ಅಂತ ಇರೋದು. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಅದಕ್ಕೆ C ಅನ್ನೋದು ಫೋರ್ತ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ P ಗೆ ಜಂಪ್ ಆಗುತ್ತೆ. ಗ್ಯಾಲಿಯಂ ನಿಂದ ಆರ್ಗಾನ್ಗೆ. ಇಲ್ಲಿ ಆರ್ಗಾನ್ ಅಷ್ಟೊತ್ತಿಗೆ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. P ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗುವಂತ ಎನರ್ಜಿ ಇರುತ್ತೆ, ಸ್ಟೆಬಿಲಿಟಿ ಇರುತ್ತೆ. ಅದಕ್ಕೆ P ಅಲ್ಲಿ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇರಬೇಕು? 6. 1 2 3 4 5 6. ಓಕೆ. ಸೊ ನೀವು ಯಾವ ತರ ನೆನಪಿಟ್ಕೋಬೇಕಂದ್ರೆ S ಅಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗ್ಬೋದು. ಸೊ S ಅಲ್ಲಿ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ? 2 ಇವೆಲ್ಲ S ಇಷ್ಟು ಒಂದು ಕಲರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ದಟ್ ಈಸ್ ಗ್ರೀನ್ ಬ್ಲೂ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಸ್ ನೀವು. ಇವೆಲ್ಲ ಕೆಂಪಿಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ, ಆರೆಂಜ್ ಕಲರ್, ಇವೆಲ್ಲ ಡಿ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ, ಇದೆಲ್ಲ ಇಲ್ಲಿಂದ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್, ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಪಿ. ದಿಸ್ ಈಸ್ ಎಫ್, ಸಪ್ರೇಟ್ ಆಗಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದಾರೆ ಎಫ್ ಅಂತ, ಯಾಕೆಂದ್ರೆ ಅದರ ಪ್ರಾಪರ್ಟೀಸ್ ವೇರಿ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಈ ರೀತಿ ಫೋರ್ತ್ ಪೀರಿಯಡ್ ಆಯಿತು. ಸಿಮಿಲರ್ಲಿ ದಿ ಫಿಫ್ತ್ ಪೀರಿಯಡ್, ಎಲಿಮೆಂಟ್ಸ್ containing how much? 14. Fourth period is 18 and fifth period also containing 18 elements. Similarly, like that, this is the fifth period. Rubidium, then strontium. Rubidium and strontium, these two belong to S block and they has ability to accumulate 2 electron, therefore 5s1 irutte, 5s2 ಇದೆ electronic configuration. Then ytterbium is started after filling 5s2. 5s ನೋಡಿ, 5s fill ಆದ್ಮೇಲೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ d ಗೆ ಹೋಗಬೇಕು, 4d ಗೆ. 5s ಆಯ್ತು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾವು 5p ಗೆ ಹೋಗಂಗಿಲ್ಲ, ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಅಕಾರ್ಡಿಂಗ್ ಟು Unsul Pauli's exclusive principle and Hubble principle. 5s, after filling 5s, we have to remove 4d. It means the d orbital is started, so that here for ytterbium the electrons is enter into d shell, that is d1 ಅಂತ ಇದೆ ನೋಡಿ, like that. ಅದೇ ರೀತಿ d ಗೆ 10 electrons fill ಆಗುವಂತಹ ಎನರ್ಜಿ ಇರೋದ್ರಿಂದ 10 ಎಲಿಮೆಂಟ್ಸ್ ಇಲ್ಲಿದೆ. Then after filling d fill ಆಗೋದು ಅಂದಮೇಲೆ ಮತ್ತೆ ಏನಾಗಬೇಕು? s ಬರಬೇಕು. ಮತ್ತೆ sorry, not s. After filling d we have to move p. d ಆಯ್ತು ಅಂದ್ರೆ ಯಾವುದು? p. 5p ಬರಬೇಕು. p ಯಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗಬಹುದು? 6 ಎಲೆಕ್ಟ್ರಾನ್, ಅಂದ್ರೆ ಫಿಫ್ತ್ ಶೆಲ್ ಇದು. ಫಿಫ್ತ್ ಶೆಲ್ ಅಂದ್ರೆ ಫಿಫ್ತ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದೀವಿ, ಆವಾಗ p ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲಿ ಫಿಲ್ ಆಯ್ತು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ದಿಸ್ ಇಸ್ ಫಿಫ್ತ್ ಒನ್. ದೆನ್ ಸಿಮಿಲರ್ಲಿ ಸಿಕ್ಸ್ತ್ ರಲ್ಲಿ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ? ಹೌ ಮೆನಿ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ದೇರ್ ಇನ್ ಸಿಕ್ಸ್ತ್ ಪೀರಿಯಡ್? ದೇರ್ ಇಸ್ 32 elements in sixth period. So what are those elements? And the beginning element of the sixth period is cesium. Cesium and barium, these two are completely filled by s orbitals. s orbital ಅಥವಾ s shell ಅಲ್ಲಿ ಏನಾಯ್ತು? ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆಗೋಯ್ತು ಬೇರಿಯಂ ಗೆ. ಮತ್ತೆ d orbital, see 6s2 ಆಗೋಯ್ತು ಸಿಕ್ಸ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ. 6s2 ಆದ್ಮೇಲೆ ಏನಿದೆ? 4f ಇದೆ, ಮತ್ತೆ 5d ಇದೆ. ಫಸ್ಟ್ 4f ಫಿಲ್ ಆಗಬೇಕು, ಮತ್ತೆ 5d ಫಿಲ್ ಆಗಬೇಕು. But here the excuse is the d orbital is filled faster than f. f ಅಲ್ಲಿ 1 to 14 electrons ಫಿಲ್ ಆಗಬೇಕಾಗಿರುತ್ತೆ. ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇನ್ನ d orbital ಗೆ ಫಿಲ್ ಆಗಿಬಿಡುತ್ತೆ. ಇದರಲ್ಲಿ ಇನ್ನ d orbital ಗೆ ಫಿಲ್ ಆಗುತ್ತೆ ಸಿಕ್ಸ್ತ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ. ಸೊ ದಟ್ ದೀಸ್ ಎಲಿಮೆಂಟ್ಸ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ಇನ್ನರ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್. ಇವುಗಳನ್ನ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಇನ್ನರ್ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಯಾಕೆಂದ್ರೆ ಬೇರಿಯಂ ಆದ್ಮೇಲೆ ನೋಡಿ cesium 56, after 56 58. For 58 ಅಲ್ಲಿ ಏನಾಗಿದೆ? 5d1 ಆಗಿದೆ, 4f1 ಆಗಿದೆ. 4f1 ಮತ್ತೆ 5d1 ಎರಡು ಫಿಲ್ ಆಗಿರೋದ್ರಿಂದ these elements we called inner transition elements, or we so called as f block elements, right? Then after filling these up to lutetium, from cesium to lutetium, then we are moving to lanthanum. This lanthanum to hafnium, thorium, tungsten and rhenium, all these elements are completely filled. Then we are moving to separately titanium, lead, bismuth, polonium, yttrium and radon. Okay, so these are the elements belongs to the p block. Those is electrons is enter into the p orbitals. Okay, that is the sixth period. Similarly, the seventh period is started from francium and radium. These two are completely filled for s orbitals. Then this is the thorium. After 89 actinium, there is a thorium. ಇವುಗಳನ್ನೆಲ್ಲ ಇನ್ನರ್ ಟ್ರಾನ್ಸಿಷನ್ d ಬ್ಲಾಕ್ ಅಲ್ಲಿ ಫಿಲ್ ಆಗುತ್ತೆ. ಇನ್ನರ್ d ಆರ್ಬಿಟಲ್ಸ್ ಗೆ ಫಿಲ್ ಆದ್ಮೇಲೆ ಈ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಏನಾಯ್ತು? ಫಿಲ್ ಆಗಿಬಿಟ್ಟು ಲಾಸ್ಟ್ ಅಲ್ಲಿ p ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಫಿಲ್ ಆಗುತ್ತೆ. ಬಟ್ ಹಿಯರ್ ಅಬ್ಸರ್ವ್, these elements are not investigated yet. They mentioned just. Okay, ಇನ್ನೂ ಇವು ಕಂಪ್ಲೀಟ್ ಇನ್ವೆಸ್ಟಿಗೇಟ್ ಆಗಿಲ್ಲ, ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. ದಿಸ್ ಸೆವೆಂತ್ ಪೀರಿಯಡ್ ಎಲಿಮೆಂಟ್ ಈಸ್ ಇನ್ಕಂಪ್ಲೀಟ್. ಸೆವೆಂತ್ ಪೀರಿಯಡ್ ಅನ್ನೋದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆಗಿರೋದಿಲ್ಲ, ಇನ್ಕಂಪ್ಲೀಟ್ ಇದೆ. ಇಲ್ಲಿ ನಾವು ಮೆನ್ಷನ್ ಮಾಡಿದೀವಿ ಮಾಡರ್ನ್ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಕಂಪ್ಲೀಟ್ ಡೇಟಾಲ್ ಅಬೌಟ್ electronic configuration and the periodic table. Classification of periodic tables ಮತ್ತೆ ಎಲಿಮೆಂಟ್ಸ್ periodic tables ನ ಕಂಪ್ಲೀಟ್ ಡೀಟೇಲ್ಸ್ ಈ ತರ ಇರುತ್ತೆ. Okay, so students, I hope you understanding. While studying this chapter, you should keep the periodic table in front of you. Then only you get easy to understand how they are arranged and what are the properties, and we have to write the electronic configuration and what are the rules we have to follow. Okay, So here the electronic configuration and elements of periodic table is completed. Then the next concept is classification of elements into different blocks. See here there is 4 blocks basically: S block, P block, and D block, F block. Okay, ಇದನ್ನು ನಾವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋಣ.